Okay, I think we are live. Hello people, good evening everyone. Welcome to the 60-second edition of Geeknight Coimbatore. Geeknight is a monthly event to share knowledge with everyone. This Geeknight is organized by a passionate group of programmers. It is also organized by ThoughtWorks. In this edition of Geeknight, we are having two speakers. Uh, One is Deepak. He is going to explain about demystifying video conferencing applications. And another speaker is Vivek. He is going to explain about autonomous vehicle tech opportunity and tech stack. So if you have any questions, please post it in the YouTube chat or Zoom Q&A session. Now I'll hand it over to Deepak.
Hello everyone. Let me share the screen first. Can you see my screen?
Yes.
Hello everyone. I'm Deepak. I'm a developer here at ThoughtWorks. My primary domains I work is in the XR domain, which is like extended reality. It's nothing but like augmented reality and virtual reality. I also work in areas related with Android and web. That's about me. And in this session of the Geeknight session, I'll be covering a topic called demystifying video conferencing applications. We'll touch a bit about like what it takes to develop a video conferencing app and what is underlying technology in that. And again, there is like due to this pandemic times, like there is a huge upsurge, like what are the new features and what are the cool features that we use in this video conferencing applications. Right. So with that, let's have a quick check, like what all are the top video conferencing applications that we have in this industry. Right. So I think most of you might have used one video conferencing app or the other in this list. There is actually a combination of like multiple video conferencing applications which are used by organizations. For example, in my organization, we use primarily Zoom for video conferencing. And like we also use the Google ecosystem. So Hangouts and the Google Chat comes along with it. Like any kind of town halls or anything, where the number of participants is exceeding like more than 500,000. That kind of like huge volume conferencing, we use something like Cisco WebEx. And also my client typically uses Teams, Microsoft ecosystem. So fortunately I have to use Teams as well in my application. And in my previous organization, I have used like different applications like Slack, Skype, things like that. So I think in your organization also, like you might be using any of the video conferencing application listed above. Right. So due to this pandemic times, especially like everyone is actually pushing to a remote first approach. So there is a huge demand or an uptick in the number of video conferencing solution. Like the number of subscribers which are onboarded to these platforms are actually multifold, especially in the last 2 years. So several of these companies might have seen like a revenue growth in a 3-digit number. Right. So all this actually is possible because of Corona, thanks to Corona. But again, like apart from jokes apart, like this is actually the new normal and that's going forward. So like companies usually adopt all these like work from home or the hybrid modes moving forward. So there will definitely be like number of subscriptions and revenue generated from these will be higher definitely for these kind of applications. So and also there are actually a lot of opportunities, especially in the gaming industry. We need to see a live feed of something like that. Obviously, a video conferencing application is required in that scenario. If you are thinking of like XR spaces like XR, like extended reality or virtual reality, there is a huge demand for video conferencing solutions. And I think the new topic that is in discussion is the metaverse and the NFTs. So in there also there is a huge opportunity, like how you can actually contribute in the video conferencing. Like a video conference solution will be an apt solution for usage in that kind of space. And not just that, like traditional call center applications, right? Any ticket kind of ticket management system is also upgrading, going digital. They're also having like in order to have a faster resolution, they are adopting this kind of solution. At least a minimum requirement in this era would be something like an audio call. So audio call is also nothing but internally it is using underlying technology of video conferencing app, which we will discuss in a moment. Right. So along with this revenue, like huge revenue coming up, these actually companies are also investing more and more innovative features, such that it is actually like if you are a developer, you might be using a lot of features which are provided by this conferencing solutions. Right. So moving forward, I will. Right. So if you think of like the different features that is available in this kind of collaboration app, I think the minimum requirement is something like a audio stream or a video stream. Then there comes something like a chat solution where you can chat with the participant, record the stream, record the call, and also like a group conferencing solution like a group call. I think this whiteboarding exercise is something which is very unique, especially useful in kind of like any kind of recruitment activities or any kind of development activities. We at ThoughtWorks definitely use whiteboarding like quite often. Right. Apart from these minimum, like what you see in the right, which are like minimum viable product, there are also like other cool features provided in this kind of collaboration apps. I think screen sharing is becoming a de facto minimum requirement. I think Zoom application itself provides a lot of features like screen share. You can annotate something like this. Then there is actually virtual backgrounds. You can see my virtual background that is actually feature on top of the camera feed. And especially when you're in a noisy environment, noisy background, there is actually a lot of investments happening in the noise cancellation technologies. Right. Apart from that, there is also like I'm just not going through entire list, but there are actually a plethora of plugins which actually provides you like a lot of in which way we can actually integrate all the solution. Classical example I can think of is like developers usually use some kind of CI/CD tool. So these CD tools are integrated into this extensions into this collaboration apps. So I get instant notification like whenever a build is read, I get a notification like saying like the build is read. Right. So all these application provides ways and means so that we can extend our application to provide a single source for everything. Right. Just clear the notifications. Right. So before moving forward, like general question, like what do you think is the underlying tech behind all these technologies? Take a moment of pause. You can use the chat group. Any idea like what kind of tech is behind the scene for this kind of video conferencing application? The organizer can also contribute. Okay, I don't think there is a clue, but let's take it up. So the underlying tech in all these technologies is nothing but WebRTC. So WebRTC is actually a decade-old technology that was actually introduced in 2011. So, but the advantage of WebRTC is it actually provides a way to establish a real-time communication. So real-time communication meaning like real-time communication, and this is actually supported by all these modern browsers like Chrome, Firefox, Opera, Safari, everything. So since the like every ecosystem, like every platform, like as like Windows or Android, all these platforms support like browser in one form or the other. So thereby the WebRTC is actually supported by all the platforms as well. So in this example, we'll be trying to develop a peer-to-peer communication. When I say peer-to-peer, it is actually one user communicating to the other user, and we'll try to develop a video streaming application where we can stream the video from one user to the other end. Right. So before moving into the WebRTC nuances, like just take a pause and think of like how like I am actually a user which is connected to internet via some ISP provider, and the ISP provider in my case is nothing but GeoFiber. So my ISP provider is Geo. This Geo provides me something like a network IP. Whenever I connect it to Geo network, it's provided me with an allocated to a IP address in the network. So in this network, right, this network is definitely not a public facing network. So this network is definitely not, I don't know what is the network of myself because it is behind a private IP. So in order to establish a WebRTC communication between these peers, first step is like to identify, expose my network as a public facing network such that I can identify or establish a communication to another peer, which is also on a public kind of network. So the technology used is something like STUN protocol. STUN is nothing but a session traversal utility for NAT. It's a network address translator. So what it does provides is like if you want to communicate between two peers like peer A and peer B, first these peers will actually check like who it will query the STUN server and come to understand like what is my address, public facing address. So STUN provides you some kind of information. Even though I'm telling it as a public facing address, it's actually not as public facing address per se, but we'll discuss more in that. For time being, we'll keep it to something like a public facing information such that I can identify the other peer and establish a direct connection between them. So STUN is the minimum prerequisite. STUN server is the minimum prerequisite in order to establish a WebRTC communication. These are actually tools which is used for interactive connectivity. This terminology is called ICE candidate. Right. So I'll move, but the previous STUN server had a lot of problems. So even if you get the public facing network address of the other peer, in natural scenario, your system will have something like a firewall and it will have some antiviruses. So this network system will block the direct connection to the other peer because the other peer's network address is not recognized by your network. So obviously there will be a conflict, and this STUNs like just knowing the other IP's address will not help in our case to establish a WebRTC connection. So what it requires is something like a turn server. So turn server is also an turn server is a concept. This is actually like traversal using relays. So what this supports is like you are using relays, you are able to communicate from one peer to other. They are able to exchange communication like data transfer. And when I say data transfer, it is like multimedia information exchange. So this turn server acts as a relay to communicate between these pairs. So the advantage is what it solves in accordance with STUN is that even though you are behind some firewall IP, the STUN servers are actually hosted in a public facing IP address with some domain name. So if the domain is not blocked by your network provider, you can simply ask it. For example, google.com. If the network provides access to that domain, so this STUN server will be hosted in some domain, and you can actually directly communicate with the STUN server such that the exchange happens between one server to other. Right. So the STUN server is actually an integral part for any WebRTC communication. So I'm just giving a link here, which is nothing but a Coturn server URL. It's an open source code base for setting up the Coturn server. If you are interested, like you can set it up. And there are actually Docker images also of this Coturn server. So you can actually simply, with the click of a command like Docker run command, you can set up a Coturn server. Right. But again, like even having the STUN server or a turn server or a combined turn server, still I don't know, like these servers only provide a public facing IP for themselves. I still don't know the public IP of the peer B. For example, if I am a peer A, I don't know the public facing IP of the peer B. So still there is a disconnect, like how we can know the others IP public facing address. Only by knowing the others public facing address by both these peers, they can establish a connection. So in order to tackle this problem, there is a concept called signaling server. So signaling server is nothing but you can relate it to something like our mail service, where you send from a source, which is a sender will be a from address. It is sending some information to the to address. So in this case, the signaling server is actually built using a WebSocket. It can be like any technology behind the signaling server can be anything, but I would recommend, like if you are building something, you can build something with a WebSocket connection. So this signaling server, what it does is it actually handshakes and exchanges the information between all these peers, so that each of these peers know what is the public facing address or the network address of the other peer. So once you know the other public facing address, you can easily establish a WebRTC communication between them. We'll go into the nuances, but as I said before, again, it is not a public facing address. It is something like a session description protocol, which is called as SDP. So this SDP is nothing but a standard. Even though protocol is there, it's not a protocol. It actually provides a standard, something like a string format. It provides a multimedia information, multimedia communication session information in the string format. It's a standard like to communicate between two peers. Right. Again, like the information is provided. Like you can go through if you want to explore more. You can actually explore more. What is a signaling server? What is SDP and things like that. Right. So as I said, like all these modern browsers provides this WebRTC API by default without the use of any extension or polymers or anything like that. So the API that we are interested in this session is actually called the RTC peer connection API. So this RTC peer connection API, what it provides is you can simply create a new RTC peer connection object, and this RTC peer connection object takes in two parameters basically. Minimum requirement is like to set up an RTC iServer. So RTC iServer, it will RTC iServer is nothing but the iServer that we discussed before, which is nothing but the co-turn server. So you provide the co-turn server URL and also the information that gathered from the signaling server of the other SDP information of the other peer. So using this set remote description, what you can do is like you can set the SDP information of the other peer, and thereby what this WebRTC API will do is it will establish a WebRTC connection between that. Once this established connection has been established, you can exchange any kind of information between them. So it also provides a plethora of other APIs, meaning like you can add a video track such that the video like multimedia information is exchanged between this WebRTC connection. So if you provide something like a camera feed will be sent from one end to the other. Similarly, if you send a mic feed, like a microphone feed, it will give you features like audio call, video call. And similarly, there are actually APIs like data channel. What this provides is you can actually chat, you can send some attachments, anything and everything is possible. So these APIs are actually used to build some of the common features that we discussed in the first part. Just going back, all these notification like annotations, it requires some kind of data transfer in between them. So all these features can be built using this WebRTC APIs. Right. So I'll take a pause here. Any questions so far? What is the technology? You can use the chat. If it is clear with everyone, we'll go with the demo application. Vishnu, are you looking at the chats?
Yeah, I was just looking at YouTube. There are no questions.
Okay.
There are some answers for your first question about TC.
Okay. Right. All right. I'll just take a 1 minute shift and set up the WebRTC connection. So in this demo application, what we are doing is I have created an Android application. So I have installed that Android application in my phone. Not sure if you're seeing my phone. Okay. So this phone, in this phone application, I have installed an APK which actually communicates via the signaling server and this WebRTC. And I have also in the other end, I have a WebRTC stream, which is like a browser user. So in this browser user is another peer. Let's set up the connection between them. Right. So what happens is net. Right. Right. So in here, I have a phone device, which is actually I am actually transmitting the video captured information directly to the portal here. So what it is happening is it is actually establishing a WebRTC connection, and it is actually in real time. You can see the video feed transmitted to the other peer, which is like an APK application. So you can see like it is happens in real time. To come in. Right. So this is my wife interested to come in video. So like, right. So anything is possible, like any kind of WebRTC application is possible. Like if you have a simple Kotlin server, a single server setup, with these two prerequisites, we can actually establish a WebRTC connection to the other end. Right. So in this example, we have only shared like a peer-to-peer connection, like it's like a one-to-one connection. But in actual requirement, if you think of it, like there is actually huge features, like you wanted to have a group communication, which is actually like a network-to-network communication. And there are actually some cool features like how can I annotate on the screen, create a virtual backgrounds, all this stuff. All these features are actually built on top of WebRTC itself. So you can think of like Ponder, like what it takes to develop such features. So with this, I'm actually concluding my session. Any questions, please post it in the chat. Thank you.
We'll just wait for a minute for any questions.
Sure.
Okay, I think I see no questions in YouTube and Zoom also.
Okay. Then I'll wind up here.
Yeah.
Over to you, Vivek.
Yeah.
Hey everybody. Nana, can I go ahead?
Yeah, sorry, just a minute. There was a question in the YouTube.
Okay. Yeah.
What do you think about HTTP 3? Will it change the way the underlying tech works for streaming data?
Right. So streaming data, like there are a lot of like HTTP 3 comes with a lot of features, and definitely the video streaming is going to be mainstream. So a lot of features will be developed on top of that, especially this NFTs, like cryptocurrencies, like Bitcoins. Everything is happening in HTTP 3. Like we are also eagerly interested, like what will happen. My opinion is like definitely there will be scope for like extending the WebRTC APIs further. There will be a lot of like features in kind of like how we can automate all this stuff, like AI, ML, definitely some scope in WebRTC as well. Any other questions, Sushma?
No, Deepak, only one.
Okay. All right. Sorry, Vivek. Yeah. Over to you.
Yeah, sorry. You can take.
Okay. Thank you, everybody. I hope people are listening in. So the second part of today's Geeknight is going to be a discussion about AV tech, especially on what AV tech means, what are the opportunities we see for software engineering in AV tech, and a short introduction to what the tech stack of AV tech will look like, and possibly announcements about the future Geeknights that are coming around. Yeah. So that's what the overall agenda is. If you have any questions, just stop me. I'm going to share my screen. Okay. To pep things up, the first question I really wanted to ask people was, I think everybody would have seen this movie by now, and it has become synonymous.
The cars, Rusty.
Yeah, I think Vivek classed.
With cars. Yeah. Am I audible now? Sorry.
Yes.
Yes. Now you.
Yeah. So what I was saying was, I think this movie has become very synonymous with cars for the new gen. Yeah. But to be really honest, when we talk about cars, what we usually come up with or what we usually think about are cars from Ferrari or cars from other brands that we know of. These have been the old bastions, and they will continue to be the bastions in the future. But the future might not look the same. The future will have more players, different players. For example, this is a player who's emerging now. Most of us will know Teslas, but this is a car from the company called Polestar, and it is actually a Tesla rival in mainland Europe. Yeah, but will cars look the same way? Will autonomous cars also look the same? Obviously not. There is going to be a lot of things that are going to change. For example, there is a startup today as we speak, which runs its cars in California. This is the startup called Zox. And if you look at this car, it basically doesn't have a driver. It's basically a cabin running around in four wheels. Yeah. So the point I'm trying to make is that the evolution of cars is going to be more than just changes or minimal changes. It is going to be complete overhauls. Yeah. But believe me, Zox did not start like this. Zox, of course, started with a tech vehicle bought by somebody else and retrofitted to work autonomously, to learn a lot of new stuff from AML, from data science, from ways sensors work, from ways how sensors can be integrated, what kind of sensors you want to use, and all of those. And that got kind of transformed into this new age or space age looking car of Zox. Yeah, that's just one example I'm trying to give. Yeah. The reason why I want to put together is I want to make this fundamental shift of idea from everybody's mind that autonomous cars are not going to look like cars of today. And the problems of autonomous cars is not a hardware problem any longer. It's actually a software problem. Yeah. And the very idea is that it is going to look as if, not look, to say the truth, the software is going to eat the car. Yeah. It's well understood now. It's a published article in IEEE Spectrum, and it is now very clearly known that the amount of code that is in the car is actually much more complex, even by just sheer volume, is more than most production systems out there. And cars, by the definition, are safety critical, yeah, and therefore much more complex and much more controlled environments of software development. Yeah. In this direction, now that we are moving away from looking at a car as a hardware or value addition being a hardware and moving towards value addition of vehicles as software, what is that opportunity that is going to happen in software engineering for vehicles? That's what we are here to discuss today. Yeah. And before we step into that, I would like to give a kind of an understanding of what this autonomous vehicle tech really means. Each of us have a different idea of what autonomous vehicle tech means. For most of us, it's just passenger vehicles because that is the only thing we have been exposed to. Yeah. But to me, AV tech is not just synonymous with passenger vehicles. It is synonymous across multiple different sectors or multiple different transportation vehicles, if you want to call it so. From passenger vehicles being one of the largest markets, but we will have autonomous vehicle tech in multiple other things. For example, if you really take a SpaceX Dragon capsule today, the Dragon capsule is autonomous. The Dragon capsule basically, once it's in space, kind of docks with the ISS by itself. Yeah, there is nobody intervening. It's docking, or there is a manual backup, but it does it autonomously. Yeah, so we have this entire spectrum, and if you go back and really think at the core, or when you put in first principles thinking and you say, what are these autonomous vehicles? Then we can say it as there is a form to them and there is a function to them. The form is basically the hardware and software coming together. And I'm really critically saying the software is also form. It is not the functionality, it is the form. The software is the form. What functionality they produce is connected intelligence. And that's how I would like to typically see autonomous vehicle tech. With that definition, what is the technicality behind it? How complex it is? Where are we today and where are we moving in the future? Yeah. If you know a little bit about autonomous vehicles, they have been classified in terms of evolution of automation from what we call as L1 to L5. L1 being driver assisted, which is you controlling the vehicle completely, and you have functionalities like power steering, you have functionalities like ABS, which kind of aid the driver. Yeah. Moving above, you have partial automation, where you have able to control the steering and acceleration and deceleration, but the car can also step in when it requires. Yeah. Then you have L3, which is conditional automation. All tasks is automated, but a driver is still required to look at the steering wheel all the time or have hands-on on the steering wheel. And when it's required, you'll have to step in as a manual operator. Then you go to L4, where you can be hands-free of the driver's seat, and the car is supposed to drive itself. And L5 is pure autonomy, where you no longer have a driver in the first place in the vehicle to begin with. Yeah. All said and done, let's keep Tesla as an outlier, but all said and done, today the world is somewhere between L2 and L3. Yeah. Though there is a lot of discussion about Tesla saying that we have done L4 or we have sent out vehicles that are L5 capable, truly not. Yeah. If you dig deep and understand the automotive sector as such. So here we are today, and what we see is the evolution from today to L5 autonomy is really a software problem. It is really a problem of different pieces in an autonomous vehicle tech. For example, it could be perception, it could be planning, it could be autonomous intelligence, it could be data engineering, but it is a software problem. The hardware problem is almost solved, or they are closer to solving hardware problems. A little bit on lidars and cameras, but it is going to be a software problem. Yeah, and this is going to account for 90% of any future innovations in an autonomous vehicle. Yeah. The other side to it is more little technical. I don't know how many of you have actually, how many of you own a car, and if you own a car, just open your bonnet and look at your engine. Near to engine, there should be sitting a small kind of a black box or a silver box. It's basically an electronic control unit. Or what I'm saying is that unaware of you, we have put already computers in vehicles. You just don't know that those things are there. Yeah, and it was done almost like 15 to 16 years back, and today we are very advanced with those computers in vehicles. Yeah, today we even have a 64-bit architecture with a server class chip embedded system sitting inside a vehicle. Yeah. So with that, today we are at a very preliminary stage. We will move into more clear architectures or hardware layouts. But what we see in the future state is we even see functions that can run on the cloud that will discuss over connectivity to a car, functions that can partially run on different parts of the vehicle. Today, the vehicle might look so, but future when the vehicle becomes much more what we call as zone driven, the architecture inside the vehicle might look very, very different to what we see today. The reason to kind of show this was for you to understand both the complexities in both the directions, because the complexity is going to rise as far as functionality is concerned, and together the complexity will also rise in terms of hardware and software functionality that has to achieve this particular automation possibilities. In another view of it, today we are somewhere in the L2 to L3 autonomy, where you have a lot of functions that kind of aid the driver a little more. In the passenger vehicle, you're yet to see it in Indian markets, but in many markets, we have already solutions. But if you move beyond passenger vehicles, you have off-highway vehicles like a tractor, which is almost L3 capable today. You have a John Deere system where a farmer can just say, plow the field and just plant this particular seed variety for me, and it does it autonomously. Yeah. In fact, if you have watched the space, like a month or back, John Deere said we have an L5 autonomous tractor in place. Yeah, but we believe there's still a lot of way to go, and the difference is today we have what is called as ADAS systems or advanced driver assistance systems. This will get converted into what is called as AD or autonomous driving, which is what the AV tech is all about. Just for the business savvy people and for really looking at where the opportunities are, just for some numbers, if you look at different pieces within the vehicle that is going to grow, there is going to be a lot of growth within the next decade. And if you look at the software part of it, combining these two numbers together, they actually outgrow all the other possible growth points of the autonomous vehicle space. Yeah, which is essentially saying people that there is a lot of software engineering going to happen, and the field is ripe enough for software innovations and software people to start stepping in. Yeah. As I was saying, a what is this software then? Okay, Vivek is talking and talking on about, okay, there is hardware, there is software. Then what is this software? What is this software going to do? Well, the software can do a lot of stuff. Yeah, the software can talk about from security in connected vehicles to personalizing a car for you. For example, today, if you own a BMW X1, you can actually sit in the X1 and say, I want it to be now a sports mode or a normal family mode. If you go sports mode, then the entire cabin changes its light. Even the way your car, your IC engine responds to your ACPAD kind of changes. Yeah. So you can personalize your vehicle for individual drivers and and a lot of other things. There is a lot of other software which needs to go on the hardware for its middle layer, and then applications. Connectivity is a large play. Then you have within the vehicle how to control the vehicle, how to distribute energy. If the IC engine is going to go out and the EV is going to come in, how do we do it in the EV engines? Or if your powertrain is going to be a multiplex of IC and EVs and different fuels, how are we going to do it? All of this is going to be software play. Yeah, this is the overall view. I kind of want to ease you into the overall view of software, but the actual software landscape of autonomous vehicles is much more complex, is much more insane, if you want to call me, because it involves everything. I have heard people say we are full stack developers, but full stack in automotive would mean very, very different. Yeah, the word full stack is hugely loaded as far as automotive is concerned. If you look at the very, very left of it, at the very bottom, you have the hardware stack. And just above the hardware, you have the off-board software and data, which means that this is going to just be outside, not run on the board, but it is going to give, it's going to control all the things that are going to go on to the, or develop the software that is going to go on the vehicle, and also get the data from there to make a lot of sense for autonomous driving. Just above that is methodologies. I think most of us at ThoughtWorks and in software engineering should be little bit aware of these terms. Maybe something that is very interesting with autonomous vehicles is, or automotive industry as such, is what we call as hill testing or hardware in loop testing, and also testing for in the vehicle itself, in your final system. If you look at classical software industry systems, or let's say you are deploying an application to a server, you have a lot of virtualization that you can do. And in many cases, the virtual testing is almost as good as testing on the target, but it is not the same with vehicles as a whole, because you are working in a very small part of the vehicle. And when you actually want to deploy something, that part, it usually touches or affects all the other parts. And it is always that every software that is going to go out is going to get tested in an integration vehicle before it is going to get into production vehicles. Yeah. And there is also the complexity of, in the future, like today, how you update your cell phones with apps and with say the OS itself. How can that happen in vehicles? These are kind of across both sides, and above is what we call as the onboard software, which means that on this hardware stack, what are you going to run? Yeah, basically a kernel. It may be Linux. It may be something else in the future. It can be a famous company called QNX. You have what we call as schedulers, especially for real-time systems. Then since they are hardware, there is some way that the software should talk to the hardware, which is the driver. Then you have the middlewares and anything that is synonymous to the middleware, which is the OS, components in the OS. The OS itself is kind of an overarching term. And above that, you have algorithms that are converted into applications. When I say applications, we are not talking about HTTP applications or applications that have connectivity, more of standalone applications that are running functionality within the vehicle. For example, AML-based understanding is a few examples that they've given here. Yeah, and above and all of this is how you are going to productize this, how you are going to package this, and how you are going to kind of put it into production vehicles, both before they roll off and after they roll off from the pads. Yeah. So from this slide, the idea that I wanted to put across is that the automotive tech stack, or more precisely the AV tech stack or autonomous vehicle tech stack, is a completely different thing from normal tech stacks that IT software engineering or software engineers work on. Yeah, and this will involve a lot of new know-how building, a lot of hands-on, and it will be especially interesting to bring software practices that we have had in the IT sector or in the IT industry or in custom software development that we are very good at, and kind of bring them to the automotive industry. Yeah, that's where the challenges are going to be. And challenges are also going to be to understand how really a problem in the automotive space or a functionality in the automotive space is going to get converted into an application in the application running on a hardware, because it is not simply going to be a UI UX experience. It is going to be algorithms that are deeply entrenched in how a vehicle works or deeply entrenched in how an automotive works, and getting those algorithms as program solved solutions onto the vehicle. Yeah. Just to kind of touch upon a little more on where the ecosystem is going. We all know that autonomous vehicle technology, no single company is capable of taking it head on, or they cannot solve the entire problem as a one single company. It is going to be very, very difficult. And how they're going to respond is that they're going to respond with a lot of ecosystem players, a lot of cooperations across different industries. In fact, the automotive space is just bustling with startups. We have had unicorns starting up. We have had even a company called Argo.ai, which is producing the middleware for autonomous vehicles, which is now Series C funded. Yeah. So there's going to be a lot of players here. There are going to be a lot of ecosystem players, and these ecosystem players are going to look for talent across the spectrum. As I was talking about the tech stack, but the challenge here is that these are going to be people who come from the software industry who are going to look at the problem differently and really make a change in how software engineering is done for automotive development with the newer tech stacks that can develop applications for the autonomous vehicle. Lastly, since this is Coimbatore Geeknight, what is brewing in Coimbatore? What is thought was going to brew in Coimbatore? We are going to kickstart a lot of different communities that are going to be in and around the AV tech space. For example, Rust. There is already an XR community that is active from ThoughtWorks Coimbatore. We're going to look at AI, we're going to look at ML, data, and those communities will be reaching out. People who are interested to be part of those communities, kind of aligned to AV tech, can also start participating. We'll be seriously building an ecosystem across Coimbatore with Geeknight as one of the main components. I'll also say why it is, but we're also looking for college corporations. We are going to look at other third-party corporations that we can do. If you're an entrepreneur and if you've already started something in the AV tech space, we'll be happy to talk with you. The third thing, as I was saying, this is new skill. We might have already done a lot of skilling. You might say that I know C++ already, but do we know C++ in terms of what automotive vehicles and autonomous vehicles need? So we are going to run a number of workshops in ThoughtWorks across India, and many of these workshops will also be a recruitment drive for us, because we are looking for people with varied skills, with C++ know-how, with Rust know-how, with CI/CD for automotive. If you know what I mean, and please talk to us if you think you have an opportunity there. Last but not the least, in fact, the most fun part of it, I'll say, we are going to retrofit a car in Coimbatore, which is going to be autonomous. We're going to bring autonomous functionality to it. It might not be a Tesla. Teslas are tough, but we are looking at vehicles from Indian OEs and see how can we retrofit and really develop our own know-how on building an autonomous vehicle. Yeah, and people who are going to participate in the communities in Geeknights are going to at some point in have the ability to sit on these vehicles and kind of drive your algos and make it run around, not the city maybe, but at least on some test tracks in Coimbatore. Yeah. With that said, this Geeknight is just an introduction, just to ease the community to what is going to come on the next Geeknight. Yeah. The next April Geeknight is going to be a hybrid one. It is going to be both virtual and physical. If people cannot travel to Coimbatore, that's not a problem. But people who can travel to Coimbatore, the office will be open for you to drop in. We are actually, because of COVID restrictions, we have some ground rules which I'll go through. But the agenda is basically to have an hands-on on hardware. We are setting up demo hardware on desk with some high-ended GPU embedded system boards. We will be able to develop an application maybe in Rust or in C++ and run it to a CI/CD pipeline with testing, with TDD developments or software practices that ThoughtWorks knows. And we're going to deploy it onto the system and see how good we can build new algorithms for autonomous vehicles. Yeah, and you can choose any use case we want. We have our own use cases in mind, but you can always come up with your own use cases and kind of use the CI/CD pipeline to deploy it in this hardware and see how that hardware is responding. The hardware will have some very nice technologies. We are looking at even virtual testing. So for people who will not be able to drop into the office, don't worry. The hardware is not a problem. We are setting up some virtual simulators for you. We will send you, people who are interested will send you. You can also set it up in your laptop and test it even remotely. But we will have some ground rules. For example, the COVID protocols, masks should be always on. There will be some kind of restricted collaboration. It will be only limited seats. 20 thought workers who is going to go to NY and get yours registered first are going to get these slots. And we are looking for 7 to 10 non-thought workers who want to participate. Thought workers have to register in NY. There's no go around it, and should show proof of 2 vaccinations. Whereas non-thought workers, please go to the Geeknight website. And if you are going to show interest to attend the Geeknight in April, we will send out a Google registration form for you. But you will also have to show 2 proofs of vaccinations. That would be the count rules. That's all from my side. Any questions I can take? Anna, you have any questions? Somewhere?
Yeah, I'm just looking into the YouTube chat. I didn't see anything. We'll just wait for a minute.
Okay.
So Vivek, I just have one question about that hardware part. You mentioned like hardware is ready up to L5, but only the software needs to be improved, right?
No. So, for example, if you look at Tesla today, what Tesla has said in the market is that my vehicles have already hardware that is L4 and L5 ready.
Okay.
That's what they claim, at least. Yeah. But what we see is that is not the truth. Yeah. And in fact, to be really honest, an L5 system will not only depend upon hardware in the vehicle, it will also depend upon hardware of the infrastructure around. Yeah. So there is still a lot of ways to go, but the hardware problem is a much easier problem to solve than the software problem.
I also just have another question to start with that autonomous vehicles. So which tech stacks are from where I need to get started as a developer or some?
So we will be introducing these tech stacks within ThoughtWorks shortly. And in the next Geeknight, we will also open up resources that can be used for people to try on their own. Yeah. To be more precise, if you want to start away with, I would say C++ will be a very interesting skill to have. Yeah. And maybe Rust.
Okay. I see no questions in Zoom or YouTube. Yeah, so I think then I'll just end the stream in YouTube. Thanks, folks, for joining. Okay.